Mike is our founder of Infovia, and then Christopher is our senior data architect. And both of them are going to be sharing a little bit about their perspectives about Data Vault, what it is at a basic level, and then dive in a little bit to the technical sides of that. So I'm going to hand it over to Christopher to begin. And before we do that, as you have questions, please put them in the chat, and then we'll answer those at the end with the Q&A time. Go for it.
All right. So as we get started here, I want to talk about the three broad types of warehouses. Those are the utility warehouse, your traditional warehouse, and your modern warehouse. You may see your own organization using many aspects of this and hopefully heavily on the modern one. Your utility warehouse, you're going to see as your operational data stores and your tabular models from Power BI or Tableau, and sometimes, often Excel files, right? So these are nice because they start out with someone who recognizes a need in the business and pulls together data from one or more systems in some handy report and says, hey, we've got this, and it serves that scope, that very specific scope. And that's so successful that someone else does it, or they build another report, and this goes on. And soon you do kind of have a warehouse. You have a lot of information sitting there. But the downside is that all of these nice reports were built with a very small scope. So model data might be contradictory between individual reports since they're actually talking about different grains of data. There isn't a lot of organization, and it's really difficult to leverage these individual, very specific reports in the wider organization. I compare this to that drawer in your house, right? It has a lot of tools that are useful for specific furniture, or maybe this one opens the awning in summer, but there's no cohesive role to them, and they don't really work well together. So that's your utility warehouse. Your traditional warehouse, can we go one more back, please? Is going to be more your Kimball or dimensional model or your corporate information factory. Now, most of us are familiar with these. You're going to have your star schema, you're going to have dimensions. It's all very nice and curated. If you want to know about staff data, you go to your staff demographic dimension. So the nice side is it's easy to parse, and it's usually considered a golden record. They say if you want to know about a staff member, you go to the staff dimension and you get this information. Now, the downside to this approach, as we have all discovered, is that this is a very complex thing to add to these dimensions and to reshuffle the dimensions as you get new data sources. And there's constantly the question of what is the golden record? And maybe finance considers the absolute golden record for employees a little differently than services or HR. So it doesn't account for different perspectives within the business, and it's difficult to add to. And the bigger it gets, the more you get these questions and the more you lose data as you filter it down to one golden record. All right, finally, we have the modern warehouse, which is what Mike is going to be talking about shortly. It's using an ensemble type methodology. You'll usually hear it called Data Vault. Some lesser known ones are called Focal Point and Anchor. And this has accounted for all these issues we found earlier. We can expand on this very quickly. Data is organized around each specific business using the vernacular of that specific business. And unlike the traditional warehouse, it's easy to add to. You have a staff hub, and you build out staff data from any amount of sources around that hub. So now it's modular. Now you're not restricted to having a gold record. It is all the data all the time. And this has been very successful. So there's been a lot of changes over. People are really coming to appreciate how much this expands your possibilities and how fast you can move. The only downsides to this modern warehouse is that it is a lot of objects to make. You have a lot going on, so automation is recommended. And the other downside, and people argue that this might not actually be a downside, is that you can't build it based on data analysis alone. You can't open up a source system and build yourself a data vault. You really need to talk to your end users, to your business people, and see how the business talks about things, because your source system is not your business. So with that, Mike is going to launch into more about this modern approach and all the myriad benefits. And Mike, you are on mute if you are not aware of that.
Thank you, Christopher. After all, speaking to the business gives us the user perspective, and that's what we're aiming for in our data warehouse anyway. We would hope that we don't build a data warehouse with no users. So I like the field of dreams. If we build it, they will come, but it has to be built to their specifications. So speaking of users, as we've worked with clients over the past 4 years as Infovia, we've amassed a set of criteria that continue to be asked for consistently in, will you modernize our data warehouse? And these are typically the things that a client or a company, an organization is looking for. So as we've served organizations from healthcare to insurance to education, both at the local and at the higher ed level, and retail, services, engineering, they all tend to want a data warehouse that can live and breathe and be iterative in nature. You could say it's agile in that it can respond quickly to business needs or changing requirements. It's also iterative in that it delivers some solutions quickly, end to end, so that you can get immediate use out of your data warehouse, as opposed to waiting for a room full of consultants to work for 1.5 years before you get to see the results. So we would prefer to have results within 1 or 2 sprints, as opposed to waiting behind that black box. The solutions, we're constantly asked for automation, in that we want to move more of the building out of the hands of coders and into the hands of pattern-based code generation. We'll talk a lot more about this as we go on. They want it to be supportable, in that it follows standards, and that one person can build something and someone else can understand it, use it, and even change it in the future if necessary. So it needs to be able to live on past the career span of the immediate team. It needs to be trusted, in both from the consumers as well as the stakeholders and the team itself. Everyone needs to be able to trust that the data is accurate, and also that it is transparent, that they can see what is happening, and it isn't a black box. It becomes a more living, breathing, and visible object or set of objects that can be used. And then finally, of course, more and more as time moves on, we realize that data is an asset and we need to protect it. Some organizations, like financial and healthcare organizations, are bound by law to protect their data. Others have a business interest in protecting their intellectual property, for example. So for all these reasons, we need to make sure that the data is seen by those who need to see it and no one else. So the keys to effective data management. If you were around over the last decade and you heard all the big data push, there was a lot of speak in the industry about just getting your data into one location, and that would be sufficient to launch into a modern data approach. And we would argue that that's kind of like your kid's bedroom. And if you've ever tried to cross a bedroom that looks like this in the dark, it can be quite painful. So if we turn some of our most expensive and most valuable resources are our analysts or our data scientists within our organization. They have a very specialized skill set, and we turn them loose on a set of data that's just pulled from various sources all into a central location. It's kind of like that drawer that Christopher referred to earlier, the utility drawer that isn't very well organized. So we would prefer, and we advocate at Infovia, to organize the data into data elements or data products that are consumable by the users and become what the users need them to be. They're also easily integrated in that you have keys that match, and where data relates to one another, it makes it easy to identify those relationships and join or collaborate or corroborate data across. And then, of course, once you've broken that data down into its components, then it's easy to build usable analytics, reports, machine learning models, or applications against that data. And so once it's componentized and organized, then the data becomes changeable because you're able to modularize and react to changes and build the new objects that the business needs and drives toward. So with that, we'll transition into the concept of Data Vault. We believe at Infovia that Data Vault is a key component, not the only component, but a key component in modernizing a data warehouse because it ticks a lot of these boxes. So let's talk first about what it is, and then we'll talk about why it ticks these boxes. Data Vault is a model. You might have heard it referred to as hubs, satellites, and links. Okay, so that's part of the solution. It's also a method. It's based on the CMMI, Capability Maturity Model, and it is founded by Dan Lindstedt on the concept of continual improvement and being able to mature our platform and our solutions to a level that they're more usable and more valuable within the business. And then finally, it's a mindset. It is a way of thinking about organizing data that is structured and standards-based and proven. And it just works. We've built 12.5 or so Data Vault data warehouses, and the patterns work, and they help you avoid some of the pitfalls that organizations fall into in organizing their data. They also help you communicate to one another because you're following known organization standards and practices. So let's look at a Data Vault model. Remember, a model is only part of the solution, but it's a significant part. So let's look at one. Let's talk about something that we all understand, the patient relationship in the healthcare industry. So in the middle of this model is the patient hub that identifies the instance of patient. So there'll be a row in that hub for every patient. So every person that might be interacting with the healthcare system, okay? And the hub has a list of unique business keys in it. So there's something called a business key that identifies uniquely that patient. Could be their name, but that's probably not unique. It could be their social security number, but that might not be available in all systems. So there's some unique set of business keys that identify the patient. Likewise, the payer, like insurance providers, would be a payer, a set of payers. Okay, so there's a payer element. There's a provider element. Those individuals and organizations that are providing services to the patient. There's a staff that reports into that provider, procedures that the patient might undertake, facilities where those procedures are performed, and then, of course, what we all know and love, the infamous claim, the claim that brings a lot of this together, the provider submitting a claim to the payer on behalf of the patient, okay? So each of these are hubs. There's a link between several of these objects that shows that there's a relationship between them. The link in this case is a multi-way link that links 4 objects together. Sometimes links can be 2-way, 3-way, or n-way. And also there are satellite objects that describe the relationships or the descriptive data about the hubs and sometimes the links. That descriptive data is, as it turns out, what changes in the data over the life cycle of data. It's the descriptive data that typically change. A hub either exists or doesn't. A row is inserted and then never changes. It's always identified as a thing that existed at one time. But satellite data tends to change over time, and so it's in the satellites where we keep that rich history of change. Okay, but Data Vault is not only a model, it's also an architecture. So here's an example of what we at Infovia refer to as our data warehouse reference architecture. So you might start with a bunch of sources, pretty typical. You load those sources into a landing area or a data lake or both. Those run through a staging area as we generate some of the surrogate keys and then load them into the raw data vault. We have a business data vault that informs that using business rules, and then the MART level objects that are consumed by the downstream users and technologies that consume those MART objects. We at Infovia also advocate for security that's built into the cake or baked into the cake. We consider security as a business rule. And so we would plug this idea that if you put your security in the warehouse level layer of your architecture, that then everything downstream from the InfoMarts and to the right, all of your visualizations, applications, even your ad hoc queries, all are playing by the same rules. So these business rules that help enhance the business vault to take raw data and turn it into information that can be consumed downstream, those business rules also include security policies. So let's talk a little bit more about this mindset of Data Vault and this idea of capturing history. You may have heard of temporal data. Some database platforms support temporal tables inherently. Others have change data capture schemes that they will capture that data. But whatever the case is, and however you capture change data in your systems, the fact is that if we capture the events at the lowest grain, what actually changed, those artifacts, those breadcrumbs left behind by our business processes, those events become extremely valuable as the foundation for our analytic processes in our organization. Because if we know what the events are, then we can, with a simple query, we can determine what was at some point in time. If you need to know what the data looked like on the 1st of January, 2021, you can go and run a query and find out, based on the change history, what a picture or snapshot of that data looked like at that point in time. So you can see what was. And then with the most recent version of what was, or your current record, you can see what is. So you can get a picture of how your business is running currently with minimum amount of latency, okay? So the whole point here is that we need to put in processes that capture the events at the lowest level of grain of change that we can, that's possible within the business process. And then, of course, the holy grail after all this is really why most of us are in this business at all, and that is we want to not only look at what happened in the past, but we want to learn from that and get better in the future. So we want to be able to predict, to involve maybe even AI, machine learning, to determine what will be in the future. Like our weatherman determines what the weather will be tomorrow based on a history of patterns from the past, we would aim to do the same thing with temporal data. So it's important to hook up to our sources and capture what we call all the data all the time. All the data all the time is a Data Vault concept that just means from your source systems, we're going to bring in all the data unfettered into the raw Data Vault. We advocate for the use of ELT processes as opposed to traditional ETL. While ETL can work for landing your data, ELT is more applicable to the cloud, because it's using minimal amount of technology to just reach out and load the data from a source to the target. And most of the actual transformation logic can take place in the database as the engine itself, rather than moving the data out of the database, transforming it and moving it back in like the traditional ETL tools do. So we advocate for ELT. We move the data into what we call the raw Data Vault. Okay, so now we're talking about the components of the Data Vault architecture. The raw Data Vault is a data model that's modeled in Hub Satellites and Lynx that changes the format of the data, but it doesn't change or changes the structure of the data and the format, but it doesn't change the contents of the data. So from the raw layer, we could always, if modeled correctly, we could always reverse engineer the source systems from which that data came. So there's historical view, the data is auditable, and we also have lineage back to the source systems, and it's trustworthy because we know where it came from, and we know what changed, and we know when it changed. And if the source system tells us, we can even tell what caused it to change, okay? But we capture all that raw data in Data Vault structures in Hub Satellites and Lynx in the raw Data Vault. Then we apply the business rules to those, and then we create what are called these user-facing views, or InfoMarts. Those InfoMarts are the window from the data to all the downstream consumers of that data, okay? And those user-facing views are what we advocate at InfoVia to enforce the security as well, so that when a user queries an object like customer or product, they only see the rows and columns that it's appropriate for them to see. So Data Vault, as we talked, is a model, a method, and a mindset. It's also iterative, collaborative, and automation capable. So let's talk about those concepts here. How is Data Vault iterative? Well, let's go back to that original model that we had. Let's start with the core components. Let's say that you started with a greenfield data warehouse implementation, and here you find yourself building components like provider, patient, and payer, and there's relationships between them. But then you realize that there's a new concept, the staff that supports that provider. Well, we can model staff, and we can add it into this model with no effect on the existing objects within the model. We simply added a staff hub, and we added a link between the staff and the provider that they support. Likewise, if we want to model procedures and facilities, it's always additive. We're not re-engineering or having to do multiple iterations or changes to the existing model. Here we're adding claims, and the claims relate to patient, provider, and payer. So again, just additive enhancements. And now we're adding satellites. Here we have a satellite that describes the provider. Another satellite that describes the provider. We could have multiple satellites describing the same object. This one has his credentials. Why is he, able to perform the duties of doctor or nurse? Okay. And there can be as many satellites as we need on any objects. Every hub would have at least one satellite. Some links have satellites as well. Here we show the satellite for the claim that might specify what the line number and amount was that was associated to that claim from that provider to the payer on behalf of the patient. Okay, so you can see that it's iterative in that multiple teams could be working on separate components, almost like dividing up a jigsaw puzzle into multiple teams and allowing each team to work on their own section or components. Eventually, that jigsaw puzzle fits together with no re-engineering because it's built in this hub and spoke model. So because of that approach and Dan Lindsted's ability to write and communicate to us in his Data Vault books, we have an integrated data model that's agile in that it can be built iteratively, and it's business focused. Some I didn't mention earlier, but you can look at these objects and a business user can read this data model. H provider, H patient, H payer, it's pretty obvious what those relate to because they're in the business vernacular and they use business terminology. Let's talk about this concept of agile or reducing error iteratively. I have worked in data projects where users have been asked to give their requirements for their data warehouse or their new report. And really, it's not fair to ask a user just to regurgitate their requirements to us. What users ultimately want is the same things we as data professionals want. We want to be able to see the data, start to glean some insights from the data, and then iteratively develop our requirements as we go. So I would submit to you that building a model is just a first step in the process. That model is going to be wrong out of the gate, but what we want to do is continually validate that model using downstream objects that the users can consume, where they can see the data that model is producing, and then they can give us feedback. And then we incorporate that feedback to reiterate and adjust the model, and then produce those results to the end user, maybe one sprint at a time, maybe multiple times within a sprint. Maybe every day we deliver a new prototype to the end users. But the idea is if we start with a model that's maybe only 60% right, but on each iteration we correct 60% of those errors, in just 3 iterations, we're already at 94% accurate for our model. Likewise, if we start at 80% in just one iteration where we correct 80% of those errors, we get to 96%. But you might be asking me, well, that's fair to say. That makes a lot of sense, but isn't there a lot of rework in rebuilding your model and reloading your data on each iteration? Why, yes, it's interesting that you should ask that, because that's why we advocate for an automation solution that complements our Data Vault model. Remember, Data Vault models are simplified. It's a simplified way of storing data because it's reduced the complexity down to a few patterns, essentially hubs, satellites, and links, and then a few optimization patterns. And by reducing the set of objects that need to be built in the data warehouse, the types of objects, then we can invoke metadata and code templates to generate not only the landing DDL or the table structure to land the data into the model, but also the code itself that is actually used to populate that. And it seems almost magic, but we've done it now dozens of times where we've sat down with clients and they've said, what you did in an hour and a half of modeling, it would have taken us a week or a month or a whole team of consultants a year to build in our old way of doing things. So the old way of building ETL code with a room full of people sitting at desks and cubicles is broken, and it needs to be changed with this process of automation and code generation. We want to take the things that are repeatable, like moving data from a source to a target, and we want to templatize those, and we want to make machines do that work so that humans can do the things that humans are best at, which is analyzing that data, looking for key patterns and asking better business questions that we can continue to iterate and improve our business processes through. So let's take the humans out of the building process and put them into the modeling process and the analyzing process. And I think I would submit to you that that's the better use of their time. Plus, automation is repeatable. There's less effort, less time, and error is reduced. So you end up with a higher quality solution. We've had clients where in just 2 iterations, we built a data warehouse that tied $32 billion in transactions out to the nearest penny in just 2 iterations. Took us weeks to build that, and under some old processes that could have taken months or years and maybe never achieved that level of quality. The other concept here is this idea that we don't have to fear rework. It's okay to build a prototype, because if the metadata is wrong and if the model's wrong, we'll adjust the metadata. And since we don't have oodles of hours invested in building out the solution, we can regenerate that solution in just a few clicks of a button of a mouse, and the data can load, and maybe even overnight, and we might have a new iteration of that even the next day that the users can take a look at. So don't fear rework, embrace it, and work on improving your model with reckless abandon, because it's not costing you immense amounts of human thought and time to build out those models. In addition to building out this code and the target data warehouse objects themselves, so the tables and the code that loads them, if you have all the metadata that can generate the code, certainly with some templates, maybe some HTML templates, then the documentation can be generated too. And the real advantage here is that if you can get documentation for almost free, and it's basically exactly matches the code itself, then it's going to be accurate. And if it's accurate and it's up to date, then people will use it. And that makes your data warehouse more user-friendly, makes it more transparent. They'll trust it. If they can go in here and see the lineage, easily see the lineage to build their data objects, or see the transformations that take place to implement their business rules, then it's easier for them to consume that data, and it's easier for them to trust. Okay, moving on, Data Vault. Data Vault is also proven, documented, supportable, and intuitive. We talked about capturing all the data all the time in a previous slide. It is proven that this approach creates a data platform that's more user-friendly and more consumable by the end users. One of the key components of building that user-friendly architecture is what we call the virtualized presentation layer. And this is key in the Data Vault architecture, but it's also key in the idea that secure data that becomes what the user needs it to be and is allowed to see is only necessary, is only possible if we virtualize our presentation layer. So what we do is, after we've ingested our data into our Data Vault data warehouse, we've modeled it into hub satellites and links, then we apply the business rules, which, as I've said earlier, can include security policies. We create these virtual objects or views that are used then downstream by all the analytics, reporting, applications, even your ad hoc SQL queries can consume these things, and we can be confident that the users are only seeing what they should see because we're pulled through the business conformed and secured views that filter the data at the row and column level. So let's talk a little more about this idea of virtualized consumption of the data, and let's talk about what format it might be needed. And this is where I want some input from you, the audience. What types of tools and what types of users do you have, and how would they prefer to consume data? Do they like star schemas? Do they just want one big flat table? Are they open to the idea of consuming, hub satellites and links? Would they prefer third normal form, or do they just want the data to look like it did in the source systems? Talk to me a little bit about that. Anybody care to share how they prefer, how their users prefer to consume data? Then I'll share what I think and some other thought leaders have said. Do we have anybody who's brave enough to suggest what may be the optimum way for users to consume the data? What model it might look best in? I'll give you a hint. We're talking about Data Vault, but Data Vault isn't necessarily the best model for the consumers of the data. They can understand it, but it's not necessarily the optimum model for users to consume the data in. Anybody want to suggest what that might look like in your organization?
Mike, this is Ravi. It depends on the business. Like my previous experience, mostly user wanted to have the data in a very information mode, which means they wanted to see the key performance metrics. So that being said, they also wanted to see everything in a dimension and fact table modeling, right?
Okay.
But the other hand, there are operational users. They wanted to see the data in a very third normal form or flat. It's kind of a flat structures.
Okay.
So that way they can run some ad hoc reports, not only ad hoc reports, like any kind of operational reports. So it's not a full-fledged data warehouse. It's kind of a operational database.
Okay, more like third normal form then.
Third normal form.
Maybe more similar to the way that it was structured in the source systems?
Not exactly.
Not
but
necessarily.
Not necessarily, but somehow they also wanted to see some performance metrics in a third normal form. So, and the other hand, of course, there are users for research purpose, like a healthcare industry, mostly on research purpose. They wanted to see like, a lot of metrics, especially a metrics, not even a descriptive attributes. So that way, I see here Data Vault on top of, we talk about business vault, right? We can create a business vault, and then they wanted to, maybe data scientist people can query some of the information directly from the business vault rather than using any dimension modeling or operational third normal form.
Okay. Well, thanks for that feedback. I think if I could glean something from that, it's the users can dictate how they want to consume the data. But I would also submit that if we as data professionals aren't making it easier for them to use the data than it is out of the source systems, have we really accomplished anything? So I would argue we probably don't necessarily want to just reconstitute it into the format that it was in the original systems, although Data Vault is capable of doing that if modeled correctly. You can build a user-facing view that looks just like the source system. Usually we want it to be integrated and abstracted into business concepts. We want a customer dimension or a product dimension or an order fact or a claim fact, as opposed to a bunch of source system name tables that are hard to figure out and hard to understand the relationships and grain and so on. So let's move forward here with the assumption that Data Vault can be used to build the objects in whatever format the user needs. If you need flat tables, you can do so. If you want third normal form, it can do that. Most of our tools, and I think Bill Inman even agrees with this, even though he doesn't agree with Ralph Kimball on much. I have heard Bill Inman say in person that he agrees that Ralph Kimball has defined the ideal model for consuming data, and that is the dimensional model. So I'm going to show and demonstrate for you here real quickly how we're going to use Data Vault to build a dimensional model using these user-facing views. And we're going to demonstrate that with these views, the data is produced to the users in a low latency, agile, and secure format. Okay, so let's look at our model. This is a subset of the model that we had earlier. And let's start with the idea that we're going to create a fact called medical claim. And the grain of this fact is going to be the claim, and its patient, provider, payer, and procedure keys are going to be part of this fact. And then there's going to be a couple measures, the amount and the line number that is associated with that claim, okay? Well, you can see here that the amount and line number are right here in the satellite. And that's typically going to be the case. That additive data is just typically going to be descriptive data. And so it's usually going to be found in some satellite, one or more satellites that hang off of one of the objects. So here we have the satellite claim. But we need the keys from that satellite. Well, of course, the satellite and the hub have the claim key within them. But if we join from that claim on that satellite into the link, from that link, we can also derive the payer key, the patient key, and the provider key, okay? And with one more hop, we can get all the way to the procedure key. So by joining from just the claim satellite to the claim link, to the payer link, and then to the procedure, patient link, and then to the procedure link, those 1, 2, 3, 4, 5 objects, by just simply joining between those objects, we can create a virtual fact that gives us our measures at the appropriate grain. And I would submit to you that most any facts can be built with just the joining from 1 or 2 satellites to a handful of link relationships, sometimes one link, sometimes multiple, but it's a very easy thing to build, and it's a very easy thing for a modern database, relational database platform to navigate at query time. And so these tend to perform pretty well, okay? Well, so let's talk about the dimension then. If the fact is that easy to build, then certainly the dimension has to be complex. Actually, the opposite is true. The dimension is even simpler. If we consider that a dimension has a surrogate key, and then usually a business key, what identifies, the human readable part that identifies that object, and then maybe some descriptive information about that object. Well, that descriptive information is likely in the satellite, and the business key and the surrogate key are in the hub. So it's a simple 2-object join to build the dimension. Then if you want to type 1 dimension, you just filter by the most recent rows in that satellite, or the rows that were applicable at some point in time, okay? So with a simple filter on the predicate in that view, you have a type 1 dimension. If you leave the filter off, you have all the history from that satellite. That gives you a type 2 dimension. So a type 2 dimension is actually easy to build because you just join from the hub to 1 or more satellites and produce a virtual object that shows all that data. So it's very easy to build a dimensional object from a data vault using this approach. It's equally as easy to build a flat view, a bunch of denormalized data. But I would argue, unless your users demand that, or unless you're like Tableau likes to consume flat objects, I would still advocate for building dimensional objects and then building flat views over those dimensions. So kind of views over the top of views. Most relational database platforms today support that view over view concept with very high level of optimization. So you don't need to fear that like you did before, say 2005, when databases tended to slow down when you had views over views. Most of them are smart enough now with their optimizers to handle that. So we've demonstrated that we can build a fact and a dimension very easily with a data vault, from a data vault model for consumption downstream. That results in low latency, agile, and then also secure, because we have those business rules supported and enforced at the data level, which is what all the consumers of the data have in common, is that data level. So we're just about done today. I don't want you to take our word for this. I wanted to plug another webinar that's happening tomorrow. The Eckerson Group out of Boston is a set of research analysts that focus on the data domain. And we read all of their reports and white papers. They're full of good insights. And these guys are led by Wayne Eckerson, and they have predictions every year about what's going to happen in the data industry. They're usually right more than they're wrong. They're not perfect, but they're close to it. And we really put a lot of weight in what these guys have to say. They have a webinar tomorrow, and they're talking about data as a product. And this seems to be a good timing, because that's part of what we're doing as data engineers when we work with Data Vault, is we're building data into a product that can be easily consumed. As they say in their description here, it can deliver a trusted, reliable data through collaborative and automated data flows. That's the automation that we're talking about. We can deliver the right data to the right user at the right time. That's where we're talking about the secure views that are polymorphic in nature and become what the user needs to see and is allowed to see. And then users at different skill levels can work together against this data product so that it's easy for our users to consume. We should be, as engineers, making it easy for people to use a product. When I hop in my car, I don't need to know what the combustion engine, how it works. I just need to know how to operate the controls at the dashboard of that car. And that's what we should be doing as data engineers as well. So don't take our word for it. Listen in, if you like, on what Eckerson says tomorrow. And that sums up our conversation today. I'd just like to, in summary, indicate that Data Vault is in fact iterative. It helps you build incrementally and deliver value quickly. It's automation capable that allows us to use templates and metadata to generate objects with higher quality and greater speed so that we're getting value in the hands of our users more quickly. It's supportable in that we understand what each other is building because we're using patterns and templates and standards. And so it's easier to support one another's work. And when your data architect leaves and goes to another company, you're not left hanging with nobody who understands your data platform. By using automation and standards, we can easily support what somebody else built. It's trusted in that it's visible. We can generate the documentation. We make it easier for the users to consume, and it's shared securely so that people only see what they need to see and nothing more. And that's a plug for our InfoSecure product. We actually plug this in with Data Vault and other paradigms like Thermal and Dimensional as well. And it can be used to manage the metadata policies that make up those secure polymorphic views, to make it even easier for the users to consume the data and make it easier for IT to manage the set of secure objects that are consumed downstream. So with that, those are some of the advantages of Data Vault and some of the best practices for leveraging it. You can reach out to myself or Christopher if you'd like, and if you have questions, we'd be happy to take them now.
Yeah, thank you, Mike. Thank you, Christopher, for your presentation today. Yeah, love to hear some questions. Keith, Brian, Jeff, Alex, Rothy. You can chat them in if you want to, or you can just speak them out. Either way is good. So I'd like to answer some questions that you saw. What intrigued you about what we talked about today, or what was a question that you thought about, during that process?
Certainly interested in Rothy's feedback too on the explanation of building a downstream virtual mart from the Data Vault. Was that useful? Do you see how that could be helpful in curating business-facing objects that make it easier for the users to consume our data products?
Yes, Mike. I do see the Data Vault is more structured way of organizing and hubbing the data, which means auditable purpose. It is very useful. Not only that, if you wanted to build any ad hoc reports or ad hoc virtualization or even data mart enhancing, it's very easy. Instead of going to the source, the data is right there in the Data Vault.
Right.
Yeah, that's a big advantage. And more than that, organizing the data in a very structured manner and auditable security wise, I see it's a big highlight, Data Vault. Other than that, I do see, because I just come from Data Lake, and after I see the Data Vault, it's very much structured way of organizing data for any time business need, you can go and take it.
Yeah, maybe that's a future topic is maybe we should have a discussion on the applicability or not of Data Vault in a data lake. That would be interesting to have that discussion someday. Well, thanks for your feedback. Anybody else?
Oh, I have one more things to say. Since I have faced a lot of issue in ETL, parallel loading, I do see in Data Vault has parallel mechanism to load the data, which will reduce the ETL timing. When people load like a 10 million record of data to data warehouse or any kind of data management, it takes anywhere between, depends upon the data, 5 hours to 6 hours, which will make executive to wait the data to see in the early morning. But I do see in Data Vault, it's loading the data parallelly, which reduce the ETL process. Yeah.
Yeah, there are some tips and tricks that we use in that. If modeled correctly and the right templates are used, then there's literally almost no limit to the amount of data that can be loaded into a Data Vault. We had 10 trillion records in one of our satellites at one of the companies that we helped. So the only way you get 10 trillion records in a table is by loading in parallel. You can't get there with any breaks on the process. So it definitely is scalable. Yeah, thanks for pointing that out. That's not something we mentioned earlier. Anybody else? Thoughts, comments, cries of outrage?
Great stuff. Thank you.
Super. So what we'll do is we will put this recording so that you can access it. We'll send that email out. If you can go to the next slide, Mike, we'd like to talk about the next webinar we're doing. That's February 24th. That's going to be at 12 o'clock Central, and we're going to be talking about Data Vault for education and antidotes, efficiencies with costs, and a modular approach. So Christopher's going to be heading that up. So we will send that out as well. And then you can join us again on February 24th. So we're a few minutes early and love to give that time back to you. So have a wonderful day, and we will send that recording out.